What's up, yo? My name is Pepe, or Albert J. Black in social media. Today is the start of a new series in this channel, the Mastering Blockchain channel, where I will take you from beginner to expert in the knowledge of blockchain technology, like Bitcoin, Ethereum, Solidity, and so on. In this video, which is Blockchain 101, or the first chapter, we're gonna go through distributed systems because they're the base, the fundamentals for blockchain technology, the consensus algorithms, and how blockchain actually works. Distributed systems are kind of simple to explain and to grasp an idea on what they are. In short, they are 2 plus nodes, minimum of 2, maximum of infinity, in theory, that connect to each other, that based on a certain activity that they have to accomplish, based on a certain goal, they produce a single result. For example, a Google search browser works like a distributed system, but we only see a single result. That's the main focus of a distributed system, that it may have 2 or more computers, nodes, agents, people, but we, the user, the end user, only see a single view, a single result. All distributed systems are wanted to have these 3 metrics: consistency, availability, and partition tolerance. Consistency just means that each node has the same data. Node meaning computer, processor, person, unit, whatever, the same thing. Availability means that each node is available when you call it. So when you want to call for some information, you want that information to be available for you because you need it. And partition tolerance means that this connection, no matter if it's broken, you still can get the single result that a distributed system produces. But we're going to explain that a little bit further in detail in this section. If you don't want to hear the further explanation, just keep going to the next part, which is the faults of a distributed system. The cap component of a distributed system is mutually exclusive to some extent, meaning you cannot have the 3 simultaneously. If you want consistency, availability, and partition tolerance in a distributed system to produce the best single result, you're going to have to sacrifice either one of them. Most of the blockchains sacrifice consistency to some extent. They want availability so that users, whenever they want, can call on their nodes, can call on their transactions, can be able, through the CPU processing power, to perform certain actions. They want that to be available for the user. And they also want partition tolerance, which, as I just mentioned, means that when a connection is broken between nodes, that doesn't affect the entirety of the system, that the system can still produce the single result. In Bitcoin, for example, we prioritize availability and partition tolerance. Inconsistency is left to the side to some extent. But it's not entirely left to the side, because consistency is achieved after a period of time. So meaning, as time and time passes, consistency will be achieved through the nodes. Meaning, we started with these nodes having the same copy of the same data, and this node doesn't have it. But as time passes, we achieve consistency through time. That's how we implement these 3 principles for distributed systems in blockchain. The next topic we're going to touch on distributed systems is faults. The main faults that we focus on distributed systems, at least for blockchains, is Byzantine faults or Byzantine, which basically means we are basically looking for malicious nodes. These are the hardest ones to deal with. For example, there's some theory, a problem. Yes, a problem that is called the Byzantine or Byzantine generals problem. But we have 1, 2, 3, 4, 5. Boom. These balls are generals. And this sort of triangle is their target. And they cannot communicate. That's in the mid 1400s, so they don't have cell phones or smartphones or any kind of communications but letters. But in order to successfully attack their target, all of these need to agree whether they're going to attack or not. But what can happen is that some malicious node, some malicious general, for example, this guy, kills the general, and he pretends to be the general and sends fake information to the other generals. So this malicious node tries to defeat them from their plan so that they fail. This is a Byzantine fault, where we have a malicious node trying to be an honest node and pass some information to our other nodes. As I mentioned, these are hard to deal with. So in blockchain, we deal them with consensus algorithms, which I will explain further down the video. The other fault we're going to talk about for distributed systems is a fail-stop fault, which only means the node is down. These are the easiest ones to solve. Let's go on to the next one, the generics of the blockchain, which are blocks, transactions, and some other data you're about to see here. These are the generics parts of the blockchain. As we know, every blockchain contains blocks. But what you didn't know is that blocks are divided in the body and the header. Each section has its own functionality. The body of the block contains all the list of transactions and some data. Keep in mind that this data inside the block cannot be large, because then the blockchain would be really large and really not that useful. But in the header of the block, we have a pointer to the previous hash of the block. This helps facilitate that we know that the block is trustworthy, that it has been verified by the blockchain. Then we have the nonce. This thing is what miners are looking for when they are mining. The timestamp, so that we can really know when this blockchain occurred, when did this block mining was occurred. So that based on the timestamp, we can go back in time and see what previous blocks have been mined before. We also have a Merkle root, which is a hash of all the transactions, the valid transactions in the block. This is really secure guys. Sorry for that word. Let's keep on going. Let's get more intellectual. First, because I want to be more intellectual. Second, because I cannot see that data from here. The operations, basically how the blockchain works when adding a new transaction. When adding several transactions, first, what happens, user A transacts with user B. That transaction gets broadcasted to the network. Then all the people are trying to find a new block. After they find it, we can say the block has been mined. And if everything is valid, we append it to the B chain. And it goes into an immutable ledger that we will talk about later in this video. Now, we're going to talk briefly about the types of blockchains. We have tokenized blockchains and non-tokenized blockchains. As their name says it, the tokenized blockchains offer incentives as tokens so that users can earn money in cryptocurrencies, in tokens. But we also have untokenized tokens. These blockchains are basically used for private storage, where all users trust each other and there's no incentive to keep the blockchain good. But we also have public, private, and side chains. What are these differences? In short, public for everyone, private for enterprises where they have like several rankings and all information, all people trust each other, or side chains, which can be mounted on top of a blockchain. For example, untokenized blockchains cannot have a native token like Bitcoin does or like Ethereum does. But on an untokenized blockchain, you can mount a sidechain, an application or something that has their own token, if you know what I mean. If you guys have any questions at all, please let me know that in the comments and I'll answer to y'all. I just want to give you information so that you can have a better life, either by knowledge or by entertaining yourself. So comment down below whatever your doubts may be. Maybe I'm not explaining their best way possible, but if you guys have any questions, just comment down below. Greatly appreciate it. And apparently we had a mess in the blackboard, the whiteboard, the transboard, whatever. We're gonna continue and talk about consensus and blockchain, the juicy parts of it all. Bear with me. This is a brief overview on consensus algorithms and consensus mechanisms in blockchain. So what is consensus, you may ask? As in a society, consensus is the agreement upon something. In blockchain, it's an agreement of rules that determine which node gets to append the final block to the blockchain. We can do this with a series of steps: the agreement, integrity, validity, fault tolerance, and termination. All nodes agree that the integrity and they validate, and then they check for fault tolerances by the end to terminate by appending the block to the blockchain. These mechanisms that are created with consensus are of two types mainly: fault tolerance and competition. Fault tolerant means that they are guided by a series of rounds, a result that is produced after several rounds have been produced, or the competition part, when nodes compete against each other so that they can validate and append the block to the blockchain. I know, I'm too serious with the glasses. Let's get rid of those. These are the basic things for consensus, but in blockchain, we also have the proof consensus that this does all that you see here: work, stake, delegate stake, PBFT, which solves the problem we were talking about earlier, that Bisante general's problem. That one, the PBFT, does state machine replication, or SMR, which basically copies the entirety of the node onto its neighbor. So if I have a phone, you have a phone, someone has a phone, we have the entire same copy of the system, of the data. So that was BBFT, SMR, does for the blockchain. How that proof helps with these steps to create a consensus and decide which block appends to the blockchain. We also have a lot of other blockchain mechanisms and proofs. Activity, which is basically proof of work and proof of stake brought together. Just if a node is active, a node being a miner per se, or reputation, storage, authenticity, authority. These three are kind of tricky because how can reputation be of use to a blockchain? Basically, it takes a view, a holistic kind of view to your miner and see like, hey, how has this guy been doing over time? Does he seem good, or she, or it? Or has he been doing, or she, or it, some bad things? So your reputation over time helps you gain kind of a ranking to decide whether you're going to append. And in some blockchains, you may get some rewards, like in Bitcoin or Ethereum, that these rewards come from the transaction fees that we all pay. But miners on these systems sometimes get paid. This is consensus. This is the last part of the video, so thank you for staying. To continue, blockchain is this. This is blockchain resumed in a single map. Amazing, right? We're gonna go through it. So what is blockchain? Blockchain is simply a distributed, immutable ledger. Ledger meaning like a database that is distributed among peers, among people, so that they have the same amount of data. And it's nearly immutable, meaning that basically no one can go and change the transactions that have occurred in the past, unless the majority, over 51% of the network, has been taken over by some malicious nodes, or as we'll learn today, Byzantine nodes. The limits that we face with blockchain technology is that it's immaterial. The privacy that users want, that I would like to want, it's not there yet because of their main benefit, that is transparent. So this is some challenge that we still have to kind of figure out how we're gonna solve. The other limit is scalability. But going to the benefits, we have that is transparent. So if you want to know what people are doing with your money, you can really just go into the blockchain, into your ledger, which is the database, and see everything that has been going on. It is cheap compared to other traditional alternatives because there is no middleman. There is no bank between me and my mom, between me and my brother. If I want to send them some money, there is no intermediary, so it's cheaper than sending money via third parties. But it's also decentralized and efficient in a way. That are the benefits and the limits of a blockchain. And what is that? It's a blockchain. But this is the technical part, the layers of a blockchain. Every blockchain, no matter which blockchain it is, Bitcoin, Ethereum, Litecoin, EOS, Cardano, or whatever you may think of, may have these layers. Most likely, it has these layers. Let's start from the bottom up. The first layer is the network, the internet connection, the TCP or the IP connection, so that all nodes can interact and share data. Up top, we have the P2P or peer-to-peer which just serves as an info propagation kind of method so that nodes can share their data. This is the connection, this is how they share their data. We have a cryptography layer so that you can secure the data, and basically it's more secure to have it like this, like hashed. Like instead of saying ABC, it will be something different. That's cryptography. After cryptography, we encounter with consensus layer, which is the next layer on the blockchain. Then execution, then application. This layer is where all the interesting stuff happens. Deployment of smart contracts, deployment of application, dApps, DAOs, and so much more that you're gonna watch next week on next episode. What I wanted to take away from this video is this blockchain is a decentralized ledger that is basically immutable. And for updates to happen, we need consensus, which has different mechanisms. Consensus. These mechanisms allow you to validate and pass data so that no malicious nodes can interfere unless they control over 51% of the network. Don't forget to like and subscribe if you like the video and you find value. Keep on watching for more in DAOs, blockchain, computer science, and so on. And follow me on Author J Black and social media if you want to know more about what I do on an everyday basis. Thank you. Have a great one.